Yes, sir, we hear.
Okay, very good morning and all of you. Very good morning. So today we have to discuss about why Komal Puneet is also is there. I think okay, Komali, Jyoti,
No,
Puneet.
sir.
Yes, yes. Very good morning, all of you. Why categorical data analysis? In categorical data analysis, importance of what is categorical data analysis? Role of measurement of categorical data. Two philosophies if you take two categorical data. Importance of categorical data. So I'm not taking the introduction part. They will ask in the examination what is the importance of categorical data analysis. But all this one is a both theory part. You have to read this one. What is the importance of categorical data analysis? They are in the short question. So we already learned regression analysis. What is the meaning of regression analysis? X on Y and Y on X. Am I correct?
Yes, yes, sir.
So regression analysis in a characteristics of interest of the population being explained is often called as dependent variable. So X is the independent variable, then Y is the dependent variable, Y is the independent variable, then X is the dependent variable. So it is also known as the response variable or explained variable or endogenous variable. While an independent variable is also called as independent variable is called as explanatory variable or exogenous variable we are taking here. So this represents the value or used to explain the variation in the dependent variable. We generally use regression of the types of models to predict the values of the dependent variable or some other characteristics of the dependent variables as a function of the independent variables. If the regression function is a linear function, we are taking here of the independent variables who have the linear regression models. So that we can usually there is continuously dependent variable. Why? Because continuously there is no gap. 1, 2, not gap is 4 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As usually there is no gap. So that's why we can take the continuous dependent variables here. So special statistical methods are required for analysis involving categorical dependent variables. Methods for analyzing one type of categorical dependent variable may not be appropriate for analyzing another type of categorical dependent. అంటే categorical డేటాలో దానికి ఇంపార్టెన్స్ ఏంటి డిపెండెంట్ వేరియబుల్ కూడా రిగ్రెషన్ అనాలిసిస్ లో we can predict the values of the dependent variables, some other characters of the dependent variables as a function of the independent variable. This is a major aspect in the categorical data analysis, as well as the regression function as a linear function is a independent variable. We have linear regression models కూడా మనం దాన్ని independent models గా మనం తీసుకోవడం జరుగుతుంది. What is the role and measurement of categorical data analysis? What is the role? What is the importance we are taking here? In regression type of modeling, the levels of measurement used to be measured, the variables play a crucial role. Inclusion of categorical variables as independent variables in regression type models does not pose a problem, as we often dummy variables as independent variables in such regression models. When categorical variables use the dependent variables in a regression model, some statistical methods are we are taking here a different type of consideration. The type of measurement used plays a vital role categorical variable of the dependent variable. We already learned the quantitative and qualitative, and the one of the directly measured and quantitative variable may be either in continuous or discrete. The continuous means there is no gap. Discrete is a gap. Continuous variable can be considered as categorical. Discrete continuous random variable considered as categorical. So discrete random variable in categorical అంటున్నామంటే అది గ్యాప్ వస్తుంది కాబట్టి. We also know that qualitative variable that cannot be directly measured, one that cannot be directly measured. Why? Because a qualitative variable often referred an attribute here. So qualitative variable may either the normal or ordinal categorical variable we are taking, that the nominal variables we are taking here. So categorical variable naturally ordered category is known as ordinal value. From the above, we can understand that discrete quantitative variables and qualitative variables, whether normal or ordinal categorical variables we are taking here. We have to study two philosophies of in categorical data analysis. One is a transformational approach, latent variable approach, and importance of the categorical data analysis. These are the most three important subtopics we have to study. This is the main unit in the categorical role, and this one you have to learn. Then I'm going to the independence and the association of attributes. I already told in the practical class independence of attributes, criteria of independence of attributes, association of attributes, coefficient of association of colligation, contingency tables, measures of association in the contingency table. So generally we taking here, and we have learned about qualitative characters here of our attributes, classification attributes and conditions for consistency of attributes data. In the previous section, we have learned the importance of the categorical data analysis. The role are very important here. Generally we say that here associated of the appear of the together of large number of cases. However, in statistics we use the terms of association in the technical sense, mean that they are associated only if they appear together in a large number of cases. Then they are expected if they are independent, or in the sections that follow the sum of the detailed independence criteria of independence, association of attributes and all measures of association. See here, what is the independence of attributes and criteria for independence here? Two attributes we are taking A and B. So 2 and B are said to be independent if there appears to be no relationship of any sort between them. For example, we denote a year being a leap year. Suppose a leap year we are taking A, and the amount of rainfall during the rainy season and being the normal by they will consider two attributes. And ఏమంటున్నాడు rainfall leap year లో దాని rainfall during the rainy season and normal లో consider the two attributes independent అనుకుంటే, as another example we may consider the event getting the head whenever a fair coin is tossed independent each. Which hand is used for tossing of the coin? When the attributes A and B are independent here, we expect the same proportion of as among B's and betas. We are taking the B and betas here. This implies when A and B are independent, we should have. So AB by B we are taking here. So AB అంటే అక్కడ ఏం తీసుకుంటాం మనము? B ప్లస్ ఏం తీసుకున్నాము? A beta. We are taking beta. Clear or not?
Yes, sir.
అంటే మనం ప్రాక్టికల్ ఎగ్జాంపుల్ లో కూడా తీసుకున్నాం. ఆల్ఫా అంటే బి తీసుకున్నాము, ఏ అంటే బీటా తీసుకున్నాము. సో ఏబి బై బి ఈజ్ ఈక్వల్ టు ఏ బీటా బై బీటా. సో ఇన్ ద above relation we are taking alpha. See here in the second condition, see here alpha b by b is equal alpha beta by beta. Exact reverse చూడండి. This is equal. So we are taking here these conditions here. Alpha beta by beta. So therefore AB by A is equal to alpha B by alpha. It is అంటే ఏలో ఏ తీసుకున్నప్పుడు ఆల్ఫాలో కూడా బి తీసుకున్నప్పుడు ఆల్ఫా అక్కడ ఏ బిలో ఏ తీసుకుంటే ఆల్ఫా బిలో మనం ఆల్ఫా కండిషన్ మనం తీసుకుంటే 9.2.1 9.2.2 and 9.2.2 and AB by A is equal to alpha beta by alpha. So A beta, another condition we are taking here. See here alpha beta I am taking here. Here alpha AB here taken here A beta. So AB అన్నప్పుడు alpha beta, A beta అన్నప్పుడు alpha beta. The condition is changed here. So A beta by A is equal to alpha beta by alpha. So these four conditions are we have learned in the class also. So therefore 1 minus AB by B is equal to, in place of B I am writing beta 1 minus A beta by beta is equal to alpha beta by B is equal to alpha beta by beta. For the sake of conservation of the above information, Puneet, you are asked in the class in the practical classes. This is A
Yes, sir.
alpha. A alpha is equal to A beta. A beta is equal to A beta is equal to total A into B AB. Then alpha into B is equal to alpha B. Alpha beta is equal to alpha B. So this value is all A. Total value is we can treat it as B. This total value treated as B. The total A into alpha we can treat it as A. What we learned in the classroom. So criteria for independence of the attributes. What is the attributes we are taking here? The relation expressed in the this one you have to see AB by B is equal to A beta by B. We are taking here. So AB, so I am taking here AB by B plus AB by B, this is AB plus beta plus beta, not that is A beta, this is AB plus A beta plus B by B plus beta is equal to AB plus A beta is equal to ఏబి ప్లస్ ఏ బీటా ఇక్కడ ఉంది చూద్దాం మీద. AB plus AB beta. AB plus A beta. What is that value?
Yeah.
Yeah, very good, Puneet. A. So therefore, beta plus beta is equal to N. Here in the table we have taken that the values we have written here. This is A beta. You have to write in your textbooks. So when A and B are independent values, then AB is equal to AB by N. So R AB by N is equal to, we are dividing A by N, B by N. We are writing the same here. This is A and B are independent of the proportion of ABs. In the population is equal, the product of proportions A is proportion to B in the population. Yes. In a similar manner, we can see that when A and B are independent, when we end in A and B are independent, in A and B are independent, we are taking. Then alpha beta, then alpha beta we are taking the condition here, alpha by beta by N, and A beta also taking A into beta by N, alpha B is equal to alpha B N, already told in the classroom structure. And that this advantage expressing criterion of independence in this manner is that second order of class frequencies are expressed as the ratio of product of first order frequencies total number of units of the population. So you have to ignore this note, but you have to learn this formula, then you can understand all these things. Clear? Clear for Jyoti, Komli and Punit? Clear?
Yes, sir.
దాన్ని బట్టి మనం చేస్తాం. So here also the same. So attribute A. So, Puneet, this is the second one you asked in the classroom. See here,
Yes, sir.
if this is B. AB is equal to what? AB is equal to A into B by N. Already we written here. AB is equal to AB by N. Correct or not?
Yes, sir.
So A beta is equal to A into beta by N. So AB by N or A beta by N, that is also equal to A. Alpha B is equal to alpha Bn and alpha beta by N, this is alpha N. So there is no change in the totals and the rows and columns. There is no change in the total of the rows and columns, alpha, beta and I alpha N. When we can express the criterion independence of the two attributes A, B and use AB and B using the second order frequency also we can do here. We can do here the same for the frequencies also. What is the formula we are writing here? See here. If A and B are independent, then we have AB alpha B. Alpha beta. AB alpha beta. AB by N alpha beta by N. We can write it or not? As per the formula, we can write it or not? AB is equal to AB by N and alpha beta is equal to alpha beta by N. So AB by అప్పుడు ఏం చేస్తున్నాను నేను దీన్ని ఇగో A beta by N and alpha beta by N. We can writing here. As per the formula, we are writing A beta by N is equal to A beta by N. A beta by N is equal to A beta. Alpha beta by N is equal to alpha beta. Or AB by alpha beta is equal to AB by alpha beta. AB by A beta cross multiplication. AB by AB beta is equal to alpha B by alpha beta. ఎట్లా రాసిన మనకు వాల్యూస్ లో క్రైటీరియన్ వాల్యూస్ సేమ్ గానే ఉండడం జరుగుతుంది. ఒక ఎగ్జాంపుల్ చూద్దాం.
సార్ ఇక్కడ కింద ఆల్ఫా బీటా
అక్కడ జ్యోతి చెప్పు. జ్యోతి ఆస్క్ మీ.
ఇక్కడ సార్ ఆల్ఫా బీటా
ఇదా
బీటా బై
ఇదా
పైన
ఇదా ఇదా ఇది చూడు. ఏబి అంటే దీన్ని ఏం రాస్తున్నా నేను? ఏబి బై ఆల్ఫా బీటా. ఏబి చూడు ఏబి అంటే దీన్ని ఏం చేస్తున్నా నేను? ఏబి బై అంటే ఏబి బై ఇది ఆల్ఫా బీటా ఎన్నట్టు తీసుకపోతే ఏబి బై ఆల్ఫా బీటా వస్తుందా రాదా?
ఓకే సార్.
దెన్ ఎన్ ఉన్న సైడ్ మొత్తం తీసుకపోతే 0 అయిపోతుంది లాస్ట్ కి. దెన్ ఏమంటున్నాడు? ఏ బీటా ఇక్కడ ఏ బీటా బై again alpha beta we are taking, n goes to one side, that is equal to 0, we are taking the condition. So that's why the condition we have to prove here. One example we have to do. A survey was carried to know the relation between level of education and economic status of a group of individuals. 70% of the correspondent are graduates while 40% are level 2. If the attributes are independent, what should be the number of graduates who are well to do? See here, let a denote of attribute. We are n is equal to how much they given?
is equal to sir answer లో ఎంత 100 అని క్వశ్చన్ ఎలా తెలుస్తుంది 100 100 అని
100 ఎలా ట్రీట్ చేస్తాం మనం? 100 ఎలా ట్రీట్
ఒక
చేస్తాం?
100% తీసుకున్నాం సార్.
అజ్యూమ్ చేసుకుంటాం. అజ్యూమ్ చేస్తున్నాం మనం. Let denote the respondent being A and B is village, then we can given the data n is equal to 100, but A is equal to 70, B is equal to 40. Correct? So the given the attributes A, B by n, A in the 70, 40, under 280 by 100, that is 28. So the attributes will be independent 28%, and graduates belong to be well-do category. N is equal to 100 తీసుకుంటాం. 70 into 40, 280, 280, 280 by 100 is equal to 28. You can do this one. This type of problems they did not give in the exam. So see here, this problem may be important. 9.3.2. Given the following data, examine the attributes independent or not. N is equal to 100, A is equal to 60, B is equal to 90, 5 is equal to 94. Attributes A is equal to AB by N. So the given data satisfies the above criterion. Hence the two attributes are independent. How it is satisfied? Tell me. AB, how much? A into B?
54
54.
AB 54.
54 by 100. 54. See here.
5400.
5400 by 100, 54. So automatically the value is satisfied.
54 is equal to 50
54. So therefore you have to do in the exam. Immediately you have to do the value and the given AB value is same. So therefore 50 is more less it should be attributes are associated, you have to tell. Then association of attributes. We have noted in the introduction of statistics of the in a technical sense of the indicate that the units appear in the larger number of cases when they are independent. Two attributes are said to be positive associated. AB greater than AB by N. Why? Because N we are dividing here. N is dividing here, so that's why it should be greater than. I'm writing here.
నెగటివ్ అయితే లెస్ దాన్
AB by N less than AB or AB greater than AB by N. So and AB less than AB by N when the all they are said to be negatively. This is positively. This is negatively associated here. So completely positive association or complete association we are taking here. In this, in all the units, we have taken the possess as attribute also possess the attribute. Then the two attributes are said to be completed positively associated or there is complete association between them. In the case of complete association, we have A is equal to B, AB, even A not equal to B also. AB is equal to, we are writing A not equal to minimum A and minimum B. So we are writing minimum A comma B within the brackets. Complete negative association and complete dissociation. Negative association or complete dissociation of that means it is a negative association. What is a negative association? If population of number of A or alpha possess B or beta, then the two attributes you are taking here, complete negatively associated or complete dissociation, both the words are same in the attributes. If AB is equal to alpha, beta is equal to 0, in some situations we have AB is equal to 0 and alpha B not equal to 0 here. So therefore AB not equal to 0 and alpha beta is equal to 0. And AB not equal to 0, then all two attributes are completely disassociated. We are taking here. So from the conditions, where the conditions is most important in the class also. I already told in the class also. Alpha beta is equal to n minus A minus B plus AB greater than 0. I told or not?
yes sir
Yeah, n minus A minus B plus N. So that is AB greater than or equal to A plus B minus N. The another formula I can use in the classroom. AB minus A plus B minus N alpha beta is equal to 0. We have to write the same part here. An example we have to see. Given the following data, find whether the two attributes are positively associated or disassociated. N is equal to 500, A is equal to 50, B is equal to 180, AB is equal to 70. So the criterion for independence, AB is equal to AB by N. So AB value, how much they given?
1 2 3
Huh?
150, sir.
70. A into B, 150 into 180. ఎంత 150 into 180? 150 into 180.
270 దాకా.
కరెక్ట్ చెప్పు పునీత్.
270, sir.
2700 by 500.
అంతే సార్.
700 by
54.
500.
అంటే అప్పుడు ఏమవుతుంది? 70 greater than 54. Correct?
Yes, sir.
So there are the two attributes positively associated we are taking here. Then if given the following data, either the same positive, say n is equal to 100, n is equal to 800, a is equal to 300, beta is equal to 40, a beta is equal to 8. Criterion for independence formula a b is equal to ab by n. So ab by n, so there is b value is there? No. There is any b value given?
Yes, sir.
Actually, this is correct, Puneet?
So
A beta is equal to A beta by n. So A beta is equal to 80 they have given. A into beta and then the 300 into 240 how much?
300 into 240, 72000.
72000 by 800.
80, 800, 90.
No,
80 less than 90. There are two attributes are not negatively associated. ఎందుకంటే ఇక్కడ బీటా రాసుకోవాలి, బి ఉంది తప్పిది. దిస్ ఈస్ బీటా ఇచ్చినాడు కాబట్టి ఏ బీటా రాసుకోవాలి. సో నెగటివ్లీ వాల్యూస్ గ్రేటర్ దాన్ వస్తే పాజిటివ్, లెస్ దాన్ వస్తే negative. We are taking here measure of association. So see here, to measure the intensity of extrinsic association, positive or negative, between two attributes we need statistical tools. These are called measures of association. In case of 2 into 2 classification, there are two widely used measures of association. One is the coefficient of association of Q suggested by G.D. Euler, and other is coefficient of colligation Y. Euler's coefficient of association Q is called, formula already told, AB alpha beta minus alpha beta AB by alpha beta plus the numerator లో ఏమైతే రాసామో denominator అదే రాస్తాం, numerator లో subtract చేస్తాం, denominator లో addition చేస్తాం. Clear? Euler's coefficient. Okay. When A and B are independent, then Q is equal to 0. AB alpha B is equal to alpha B into A beta. When A and B are completely associated, Q is equal to +1. When in B are completely dissociated, Q is equal to -1. So coefficient of colligation in attributes data, another statistical measure that widely used to measure the nature and the intensity of association between two attributes is the coefficient of colligation Y. It is defined as follows here. The formula of the colligation Y is equal to under 1 minus under root of A beta by alpha B, AB alpha beta, 1 plus A root 1 plus A beta alpha B by AB alpha beta. I already covered this one in the Euler's coefficient, also a coefficient of colligation. When A and B are independent, then Y is equal to 0. When the two attributes are completely associated with Y is equal to +1, when they are completely dissociated, Y is equal to -1, we can easily verify that the coefficient of association Q and coefficient of colligation Y are Q is equal to 2Y by 1 plus Y square. So one problem we have to do here. From the following data, calculate Euler's coefficient of association of colligation. Also numerically verify the relation Q is equal to 2Y by 1 plus Y square. N is equal to 100. A is equal to 40, B is equal to 20, AB is equal to 9. A beta, and the formula is Puneet, A minus AB, correct? A beta is equal to A minus AB. A minus AB, and 40 minus 9, 31. Alpha B and B minus AB, B minus AB, 20 minus 9, 11. Alpha beta, formula N minus A. N and the 100, B and 20, 80, 100 minus 40 minus 20, and 100 minus 60.
109 minus 60.
100 minus 60, that is 40. 40 plus 40 plus 9 is equal to 49. 40 plus 9 is equal to 49. Just a minute. So alpha beta n minus a minus b plus ab is equal to 49 we are taking here. So 100 minus 100 minus 60 and 40, that ab is equal to 49. So that's why they written. Formula. చేసి నాకు వాల్యూ కరెక్ట్ వచ్చిందా లేదా చెప్తారండి ప్లీజ్. ప్లీజ్ డూ యువర్ ఫాస్ట్ ఇన్ రఫ్ వర్క్స్. పునీత్ అండ్ జ్యోతి అండ్ కోమలి. మేక్ ఫాస్ట్. ఒకరు క్యూ చేయండి, ఒకరు వై చేయండి. కోమల్.
అక్క మీరు వై చేయండి అక్కడ నా దగ్గర
0.1278
క్యాల్కులేటర్ లేదు.
సార్ క్యూ వచ్చింది. 0.1278 వచ్చింది.
ఓకే, నో ప్రాబ్లం. క్యూ వై. Y value.
One minute. Sir, 0.553. 0.0553, sir.
No.
0.0553.
So okay, once cross check and you can use the 2 into 1 by 1 plus y square. The answer may be come. అది ఒకసారి చూసుకోండి, తప్ప కరెక్టా నేను చేయలేదు. ఒకసారి do it. Okay. The another example, the following data relates the vaccination against the particular disease and incidence of the disease. Calculate Euler's coefficient of association, coefficient of colligation. Incidence, vaccination, vaccinated, not vaccinated. వైరస్ అటాక్ అయిన వాళ్ళు కోవిడ్ అనుకుంది, కోవిడ్ అటాక్ అయిన వాళ్ళు వ్యాక్సినేటెడ్ వాళ్ళు 81, నాన్ అటాక్ 579, నాట్ అటాక్ 248, కాని వాళ్ళు కాని వాళ్ళలో కూడా వ్యాక్సిన్ 248 అయింది, వ్యాక్సినేట్ చేసుకున్నారు, కాని వాళ్ళు 92 తీసుకోలేదు. సో సపోజ్ స్టాండర్డ్ వ్యాక్సినేషన్ బి స్టాండర్డ్ ఫర్ అటాక్డ్ బై ద డిసీజ్ ఫ్రమ్ ద గివెన్ డాటా ఈజ్ సేమ్. ఏ ఈజ్ ఈక్వల్ టు ఎంతమ్మా? ఏబి ఈజ్ ఈక్వల్ టు 81, అవునా?
AB 81.
A beta 248. A beta 248, correct?
కాదు సార్ 539.
A beta.
A beta 579 కదా.
ఏమేమి ఒక్క నిమిషం.
మనం ఇది A B ఆల్ఫా బీటా కదా సార్.
జర ఒక్క నిమిషం. AB A beta. AB A beta alpha B alpha beta, correct? AB A beta alpha B alpha beta. Okay. AB 81, A beta 579. You have to mark the change, okay? A beta 579, alpha beta 248, alpha beta 92. Clear?
Alpha B 248, alpha beta 92.
Alpha beta. ఒకసారి AB 81, A beta 579, alpha B 248, alpha beta 92. If ఆ ఫార్ములా వేసి నాకు ఆన్సర్ చెప్పండి మా ఫాస్ట్. Q value and Y value.
Sir, last started.
Okay. Okay, leave. So Puneet, this is you have to calculate calculate the coefficient of coefficient of colligation, that is a Q and Y we are taking here. Then contingency table, already I told, consider an inquiry in which the attribute A has as M sublevels and the B attributes has N sublevels. Then the total number of units in the population, N is individuals in 10 into classes. This data can be conveniently represented in the following table. M rows and N columns, it is called as M into N contingency table. A by B, A1, A2, A3, that is total AM. B1, O11, O2, O2, O22, O31, that is OM1, that is B1. O12, O22, O32, that is 13, O13, O23, O33, that is 1, and so on. B1, O1N, O2N, O3N, and so on, ONM. That is totally called as A1, capital A1, capital A2, capital A, so on, AM. That is total is equal to number N. In the above table, OIJ indicates ith row and jth column, indicates observed frequency ith row and jth column of the contingency table. The time also sometimes is denoted by AI, BJ. Since there are M rows and I values 1 to M, likewise where F values range 1 to N. Moreover, from the above table, observe the following relations. A is equal to summation of J, OIJ. BI is equal to summation of J, OIJ. We are taking these conditions here. So therefore, summation N is equal to summation of I, A, J is equal to summation of J is equal to BJ. Both the way, let's say, are calculating when the attributes A and B are independent, the independent overall sublevels of A and B. The expected frequencies of the cells under assumptions are denoted by EJ. These are calculated using the formula EIJ is equal to AI BJ by N. So therefore, I is equal to 1 to M, J is equal to 1 to N we are taking here. I already told the methods of classification for manifold classifications told in the classroom. In the contingency table, we have the following measures to know the intensity of the association between the two attributes. One is square contingency. This is denoted by the symbol chi-square. Chi-square means X is the, we are cutting the same chi-square formula, writing here summation of I is equal to 1, summation of I is equal to 1 N OIJ minus EIJ square by EIJ. So I already told this formula in the classroom also. Mean square contingency, another measure of association is the mean square contingency, which is denoted by the symbol phi square. So pi square, PHY, SUKURE, pi square in the words. It is denoted by pi square is equal to chi square by n. Chi square by n we can write here. The values of contingency and mean square contingency will never be negative. Coefficient of contingency. This is proposed Pearson and it is defined by C is equal to under root of chi square by n plus chi square is equal to, already told, chi square and under root of pi square by 1 plus pi square we have to write here. No sign will be attached. The square root of C indicates here whether we are taking two attributes are associated or not here. This theory part. Shushpro coefficient, that is T square is equal to pi square 1 root of m minus 1 and n minus 1. So yeah, what is m and n? Komal, m is repeated times and n is also repeated times. That is what we are writing Shushpro's coefficient. Suppose one example we are taking here. For the data given, the following contingency table calculates square contingency and mean square contingency, here Carl Pearson coefficient contingency, Shushpro's coefficient of contingency. See here, A1, A2, A3, 70, 38, 48, 62, 81, 80, 23, 10, 40. We are taking here, see here, 70, 30, this is 16, 4, 3, 8, 8, 4, 3, 7, 156, correct? Total 1, 2, 3, correct? And 16 or 22, correct? 3 correct, 4, 2, 73 correct. Total 155, that is 9, 14, 14, 22, 2, 3, 4, 2, 9, 5, 14, 14, 14, 22, 2, 3, 4, 5 ఇది 5 వస్తా చూడు పునీత్, ఇక్కడ 5 వస్తా చూడు పునీత్, అక్కడ 5 వస్తా చూడు ఒకసారి క్రాస్ చెక్ చేసి టోటల్ ఒకసారి క్రాస్ చెక్ చేయ ఒకసారి. 132, 132, 142, 152, 150 కరెక్ట్. 30, 80, 90, 100, 128, 129 correct. 120, 120, 160. ఎంత వస్తుంది?
452.
9, 14, 14, 22 2 కాదయ్యా. ఇప్పుడు ఈ మూడు
6, 4, 10, 10 plus 5, 15.
కాదు. ఇప్పుడు 5 +
5,
9 ఎంత? 14.
14.
14 + 8 ఎంత?
14 plus 8, 22.
ఇక్కడ 2 వస్తుంది.
ఇక్కడ 2, 6 plus 4, 10 plus 5, 15. 5 ఇక్కడ 1, 4, 452.
నేను కాలం చేస్తున్నా. కాలం ఇప్పుడు
ఇదే కదా సార్, ఇది 155, 129, 168.
9
అదే
5
452 వస్తుంది.
9 5 14, 14 22
8, 22,
2
2, 6 plus 4, 10, 10 plus 4,
మళ్ళీ
15.
6 ఎక్కడిది? ఓకే కరెక్ట్. 5 to 7, 7, 7, 9 or 15. ఓకే, 452. కండిషన్ ఈజ్ సాటిస్ఫైడ్. నేను ఆ మధ్యలో మర్చిపోయా. 452. సో దేర్ ఫోర్ ద అట్రిబ్యూట్ attributes A and B are independent with the following the formula same. So E11 Ij is equal total ith row and total jth column we are taking here. E11 is equal. How it is came? 53.4956.
155 into 156 by 452.
Again tell me 155 by
155 into 156 by 452.
Row into column by total. First row into first column by total. E12 and 155 by 223 into 452. 155 by 73 into 452. So E11, that's the values we are finding here. So therefore we are written here to calculate the measures of association OIJ minus EIJ. So therefore OIJ minus 70 minus 53, 16 minus 50.4. So directly the step OIJ minus EIJ whole square 16.051 whole square into 16.051 whole square. Then after the coming the value, then the output is that output value by division of 53.49 by 6. The total value is 27.2392. Then chi-square is equal to, we are writing here, summation of I is equal to 1 to m, summation of j is equal to n, OIJ minus EIJ square by EJ. So we can write this value 27.2392. So this is at a total coefficient also. You can substitute the same. Clear any doubts?
Clear, sir.
Okay, this is the most important problem in your exams. The following data relates to the proficiency is a music of group of mothers and that of their daughters. Calculate the square contingency, mean square contingency, Carl Pearson coefficient contingency, and Shushpro coefficient contingency for the given data here. Proficiency in music of data. So low, medium, high, total. Here also the same. Total 98. Say what a total ichad annitiki. Total is 558. I thrown jth column 227 by 199 into 558. 227 by 250 into 558. 227 into 107 into 158. Again 191 by 199 into 58. 191 by 252 into 558. 191 by 107, 558. 140 by 199 into 558. 140 into 252 by 558. 140 into 107 by 558. These values E11, E12, E13, E21, 22, 23, 31, 32, 33. We are finding the values. Same data, the values here. The square contingency, mean square contingency, and Shushpro coefficiency doubts. Bhavani, clear any doubts?
Yes, sir, clear.
Student, most important long answers. Why you help a suitable example of the contingency table. Explain the use of different measures of association. Procedure of the calculating square contingency, mean square. ఇప్పుడు నేను చెప్పిన theoretical part. Puneet.
Yes, sir.
Explain the procedure అంటే procedure చేయాలి, problem అంటే problem చేయాలి. So sample random sampling, simple random sampling. Define the simple random sampling. Simple random sampling is the technique is drawing a simple way population has in equal and independent chance being included in the sample here, or a process of drawing sample size from population size then in such a way that each of the population is chance is known as simple random sampling. Depending upon the nature drawing simple random sampling is classified in two types. One is without replacement, one is with replacement. Clear? Simple random sampling is without replacement and with replacement. So in without replacement, we are doing it in simple random sampling. Already told in the class, first drawn population is not repeated before going to the next draw. Then not repeat that is called a simple random sampling with repeat without replacement. Repeat with replacement. So if select the n size of population n without replacement, we can write NCN possible of samples. With replacement, we are taking here the simple random sampling in the first drawn population replaced before going to the next draw. Then it is called simple random sampling here. If the select sample size from a population of size, then n power n sample sizes we are taken here. Then the selection of a sample random sample. A selection of a simple random sample. So therefore, random sample refers to the method of sample which every time has an equal chance to being selected. But the random sample does not depend upon the method of selection only, but also on the size of the nature of the population. Some procedure which is simple, a good for small population, is not for the large population. Generally, the method of selection should be independent of the properties of sample population. The simple random population selected by any one of the following method. One is lottery method or a random number method. Lottery method. This is the simplest and easiest method drawing the simple sample from a population simple random sampling method. Suppose we want to select an observation of population size, then first we assign the number 1 to n to each and every observation once and only. Write the numbers of our homogeneous color, shape, width, height, etc. So slips and put these in a box. After a while, well shuffle we are taking here. Draw observations we are taking here one by one. The number of corresponding observations selected on slips. So this method selecting a random sample here. Random number mechanical random you have to do here. I did not telling these one most not clear. Notations are in terminology. The most important notations on terminology. The population y n bar 1 by n summation of y is equal to 1 to 1i. The sample mean already told in the classroom y bar n is equal to 1 by n summation of y is equal to 1 to n yi. The sample mean yn may also be written maybe alternately yn bar is equal to 1 by n summation of y is equal to 1 ai yi. So a is equal to 1. 1 ante if ith unit is included as a sample, 0 is not included. అంటే 1 తీసుకున్నప్పుడు ith unit include అవుతుంది, 0 తీసుకున్నప్పుడు include కాదని మనం అంటున్నప్పుడు ఫార్ములా mean square of the population s square is equal to 1 by n minus 1 summation of y is equal to n yi minus yi minus yn square 1 by n minus 1. Again I am doing summation here. కలుపుతున్న దీన్ని నేను summation of n ya square minus summation of this yn whole square you can write here. Small a capital N y square yn square we can write here. So mean square of the sample also, so s square is equal to 1 by n minus 1 summation of y is equal to 1 to n y minus y bar n whole square 1 by n minus 1 summation of y is equal to 1 y square minus n y n minus 2. The population parameters will use denoted by either capital letters of the English alphabet or Greek letters are and their estimates, which are function of the sample observations, are denoted by either small letters by putting symbol caps on the corresponding parameter. Thus, yn cap indicates the estimate of the population mean. So see here, sample mean and population mean. They will ask the distinguishing between sample mean and population mean. You have to write sample mean. Sample mean is in the n, small n. The population lo mean is capital N. We both are NA, but in the small n తీసుకుంటాం, ఇందులో capital N తీసుకుంటాము. ఇందులో sample units are small y1, small y2, small y3 and so on yn. ఇందులో capital Y1, capital Y2, capital Y3 and so on capital Yn. The sample value total is small y1, small y2, small y3, capital Y1, capital Y2, capital Y3. The summation of y is equal to 1 to small y, summation of y is equal to 1 to n capital Yi. So here also the sample mean here, sample size of 1 y bar n is equal to 1 by n summation of y is equal to 1 to n. Small yi, capital Yi. So the sample mean square, s square is equal to 1 by n summation of y is equal to yi minus y bar n, small letters and capital letters. Therefore 1 by sample lo any small letters vaartam, population lo any cap letters vaartam. Clear Puneet? Okay. Theorem
Yes, sir.
simple.
Yes, sir.
Theorem Simple random sampling, very most important. They will ask 101% this question. Show that simple random sampling without replacement, the sample means unbiased estimate of the population. E y bar n is equal to y bar. Then the sample mean is equal to population mean. Avuna?
Sir.
Sample mean is equal to population. Y bar n is equal to 1 by n summation of I is equal to 1 to n ai yi, where I is equal to IT unit is called in the sample 0. IT unit is not included in the sample here. See, very much more important here. E y bar n is equal e ని బయటికి తీసుకొస్తున్నా 1 by n summation of I is equal to 1 to ai. ఎందుకు బయటికి తీసుకొస్తున్నామో ఇగో ఇక్కడ ai ఇచ్చినాడు మనకి. సో 1 by n y bar స్మాల్ y bar n ఇచ్చినాడు కాబట్టి స్మాల్ y bar n వాల్యూ ఇచ్చినాడు ఇక్కడ 1 by n summation of I ai అదే రాశాను. ఈ బయట అట్లే ఉంచి 1 by n. సో summation of I is equal to 1 to ఈ ai summation of ai ని తీసుకుంటే ai ని తీసుకుంటే ఇక్కడ చూడండి ai ని తీసుకుంటే e of ai e of a అన్న సేమే. సో therefore e of a is yi. So e of a is equal to 1, pa is equal to 1 plus pa is equal to 0. ఆ వాల్యూస్ మనం సబ్స్టిట్యూట్ చేస్తున్నాం. ఎందుకు చేస్తున్నాం అంటే సిగ్మా సమ్మేషన్ ఆఫ్ ఈఏ అంటే వాల్యూస్ 1, p అంటే ప్రాబిలిటీలో 0, then it is equal to 0. I is equal to 1 is equal to p, I is included sample of size of 10 and 0 p I not included size of n. We are taking this one. So therefore formula 1 by small n by capital N and 0 into something is 0, therefore n by n. Hence we are taking here hence we are taking a small n by capital N. E y bar n is equal to 1 by n summation of I is equal to 1. Small n by capital N, this value is capital N by yi. So 1 by n. So the small n, we have small n get cancelled here. Small n get cancelled here 1 by n. So 1 by n summation of yi. So small I y into capital I, this question what is e y bar n is equal to small y bar n is equal to capital Y bar n. It's most important. Any doubt, ask me. I will clarify again, please. Punit and Bhavani.
So okay, sir.
Okay, good. Practice cheyali. Compulsory. Maybe ask. Here, in simple random sampling without replacement, the sample mean squares are unbiased estimate of the population mean E s square is equal to small s square is equal to capital X square. So see here, s square is equal to 1 by n minus 1. So E s square is equal to summation of I is equal to 1 n I y square n y n whole power of minus 2. So 1 by n minus 1 బయట తీసుకొస్తున్నా. Summation of I is equal to 1 to n y square. ఇక్కడ 1 by n ను 1 by n లో, సో 1 minus 1 లో 1 by n లోపల తీసుకొస్తే ఈ బయట తీసుకున్న minus 1 by n ని తీసుకొస్తే summation of I is equal to n I y square. Here keep that y 1 by n minus 1 summation of I is equal to 1 to n y square minus 1 by n summation of I is equal to 1 to n y square. The summation of I is I not equal to j not I not equal to 1, j is equal to 1. So therefore yi yj the రెండు కండిషన్స్ తీసుకుంటాం ఇక్కడ yi yj y అయినా yj రెండు I not equal to j is equal to 1 కాబట్టి రెండు తీసుకుంటాం కాబట్టి yi yj we are writing here. So 1 by n minus 1. So 1 by n minus 1, this I am taking here, the cross multiplication here we are taking here. So 1 by 1 minus the summation of y square. Again 1 by n, and 1 by n by n minus 1, 1 by n minus 1, 1 minus 1 by n, summation of I is equal to 1 y square. 1 by n into n minus 1, summation of I not equal to 1, j is equal to 1 to n yi yj. So 1 by n minus 1. So 1 by n, 1 minus n by n, and n minus 1 by n. So n minus 1 by n summation of I is equal to 1, and then simplification is summation of I is equal to 1, y square by y into n minus 1, summation of I is not equal to j is equal to 1, yi yj. Summation of I square మనం యాజ్ ఈజ్ అట్లే రాసుకుంటాం. 1 minus 1 by n మనకి ఇక్కడ రిమూవ్ అయిపోతుంది కాబట్టి సో e of s square is equal to 1 by n e I is equal to 1 to n y square minus of 1 by n into n minus 1. So e summation of I not equal to j is equal to 1 to n y I yj. That is equation number 1 we are taking here only. And we have already told that we have 1 is ith unit is included as sample. 0 is ith not included the sample here. So I is equal to 1 to n ei by a square. So ei 1 square I am simplifying small n by small n by capital N. Summation of small n by capital N. So summation of I is equal to n by a square we are writing here. So therefore capital E summation of I naught equal to 1, j is equal to 1. Y, yj for the earlier equation summation of I naught equal to j is equal to 1. Ai, aj, yi, yj. So summation of E, ai, bracket a, aj, close bracket here. That is we are writing I into pi, pj, a. A is equal to 1. 1 ను 0 ను మనం సబ్స్టిట్యూట్ ఇస్తే a is equal to 1 ఇంటర్సెక్షన్ ఆఫ్ a is equal to 1 గా సబ్స్టిట్యూట్ చేస్తే ఫార్ములాలో m into n n into n minus 1 by n capital N into n minus 1 ఒక శాంపిల్ సైజ్ పాపులేషన్ సైజ్ మనం కనుక మల్టిప్లై చేస్తే ఈ aij is equal to n into n minus 1 by capital N into n minus 1. So e summation of I naught equal to 1 j. So therefore summation of I naught equal to 1 j is equal to 1 n into n minus 1 by capital N into n minus 1. So therefore substituting these values here, e of s square 1 by n summation of I is equal to 1 y square by 1 by n minus n into n minus 1 by summation of 3 value I naught equal to 1 j is equal to 1 to n summation of yi yj. These values are simplifying here. E of s square is equal to s square is the most important theorem for your main exams. The sample mean square is 1 biased estimate of the population mean square. Next class లో 10.5.3 without replacement లో ఇది కూడా ఇంపార్టెంట్ s square by n minus n by n ఇది ఒకటి చెప్తూ 11th and 12th units కు పోతా. Any doubts? పునీత్ అండ్ భవాని
లేదు సార్.
No, sir.
ఒకసారి చదువుకొని రండి. నెక్స్ట్ క్లాస్ లో ముందుకు పోదాం. ఓకే కాదు
సార్.
ఇప్పుడు 5-6 minutes లో సరిపోదు, ఇది టైం తీసుకుంటుందని చెప్పట్లేదు. మోస్ట్ ఇంపార్టెంట్ కాబట్టి ట్రీట్ ఇన్ ద నెక్స్ట్. ఓకే థ్యాంక్ యూ.
థ్యాంక్
యూ హావ్ టు 10.5.4 కూడా ఒకసారి చదవండి. 10.5.4, 5.5, 5.6 చదివితే ఇంట్రొడక్షన్ సరిపోతుంది.